Well, in this video, I would like to talk about graphing linear inequalities. So I'm going to go ahead and tell you, if you're not good at graphing linear equalities, in other words, graphing straight lines, go back and get good at that, because this is going to go fast as far as the graphing goes, but I want to just point out very quickly what it means to graph an inequality. And I'm going to show you all four of these problems on this same XY axis. So first of all, I want to graph y equals negative 3x plus 5. Okay, so not the red one, right up here, y equals negative 3x plus 5. So remember to do that. That's already in what we call y equals mx plus b form. Okay, so my 5 is my y-intercept. So I go up to 5 and I make a mark. My slope is negative 3, but it has to be written in fraction form, so it's negative 3 over 1, which means we go down 3 and right 1. It's also okay to take the negative to the bottom and go up 3 and left 1. So I'm going to do down 3, 1, 2, 3, and right 1, and I could do it again, down 3 and right 1. And I connect the dots. And there is my straight line. Well, it's supposed to be straight anyway, so just assume that that's my straight line. Now, what I want to spend my time doing is talking about what it would look like if I was to shade y is bigger than negative 3x plus 5. So first thing, if it's got an equal to, a greater than or equal to, or down here like in the blue, a less than or equal to, but we're going to focus on the red one, then you need a solid line, just like I have here. If y is greater than that, that means y is bigger than this line. Well, all the y's bigger than this line are on this side. Okay? So everything on this upper side of my line would make this true. Like if I pick a random point, like let's just say this point right here, which happens to be 5, 4. If I plug that in and check, so y is 4, is that greater than or equal to 3 times negative 3 times 5 plus 5. We're just seeing, is that true or is that false? Well, that's negative 15 plus 5, that's negative 10. Is 4 bigger than or equal to negative 10? Sure is, it's true. Turns out everything I've got shaded over there is going to make this inequality true. Okay? Now I'll give you a better idea about how to know what side to shade as we progress, but I just want you to see what a solution to this is and what that looks like. Now I'm going to get rid of my red and show you what the difference is between y is greater and y is greater than or equal to. We just did a greater than or equal to. So in purple, and let me just erase right here, we're going to do the same line, okay, but y is greater than negative 3x plus 5. So let's get the purple on. There it is. I graph the same way. I graph the equals problem up here. So y-intercept is 5. I count down 3, right 1. I could do it again, down 3, right 1. There it is. But this time, since there's no equal to, I graph this thing with a dashed line. There we go. But since it says y is greater, now think about it. To the left, y's are less, because to shade any of this in, you're talking about y smaller than our y value. But if I shade this side in, all these y's, no matter what the x's are bigger than the line. So again, anything that I just shaded is going to make that inequality true. I'm not going to pick a point to test, but it would work. Okay? Alright, so there's the purple one. Now let's check out the blue. What's the difference? Well, the equation is the same, but it's got an equal to right here. Okay? Less than or equal to. So I'm going to graph this one with a solid line, because less than or equal to is a solid line. Again, my y-intercept is 5. I count down 3, right 1. I could also go up 3, left 1. That gives me that same line. I'm going to make it solid because of the equal to in the problem. But this time it says y is less than that line. So all my y's less than that line are on this side. That means every single, and that goes on forever, right? Every single value on this side is going to make that inequality true. And we could pick a point to test. You see, there's one right. Well, how about that guy? He's shaded in, right? That point is negative 10, 0. If I plug negative 10, 0 into my inequality, I would have 0 is less than or equal to negative 3 times negative 10 plus 5. Now, is that true or false? Is 0 less than or equal to, that's 30 plus 5 is 35. Well, sure enough, that's true, right? And everything that I've got shaded in over here is going to make that true. You got that? Finally, let's do the green. Okay, so I'm going to erase. I'm going to graph this thing one more time. So when I graph, I'm actually graphing the equals problem. So I'm graphing y equals negative 3x plus 5. And the y-intercept is still 5, and we're still going down 3, right 1, down 3, right 1, or up 3, left 1. But now there is no equals here. So that means when I graph this and I connect the dots, I'm doing it with a dashed line, okay? Dashed line, not a solid line, a dashed line. Now it says my y's are less than that line. Y is less than anything on that line. So all my y's less than that line are on this side. And again, I could check it and see if it's true. Now, what's up with the dashed line? Well, the dashed line means anything that's on that line will actually not make this true because there's not an equal to there. Remember, anything on that line, it makes it equal. So anything below that line, in this case, is going to make that inequality true. Now this time, let's don't do the quick view. Let's go step by step exactly how you will do every one of these problems. Notice it says graph the linear equation. We're going to graph y is greater than negative 4x plus 1. So notice step 1 here says graph the line with an equals in place of an equality. So step 1, I want to graph y equals negative 4x plus 1. Okay, now the good news is that's already in y equals mx plus b form, so my y-intercept is 1, so I'm going to make a mark there. And my slope is negative 4. So that means I go down 4, and don't forget that's over 1, and right 1. From my y-intercept, so I count down 4. 1, 2, 3, 4, and I count right 1. And I can do it again. I count down 4. 1, 2, 3, 4, and I count right 1. Okay, now step 2 says use a dashed for less than or greater than, or use a solid for less than or equal to, or greater than or equal to. Well, we have a greater than in our problem, so we're going to use a dashed line. So you get out your ruler, which I do not have on me right now, and I'm just going to do a dashed line through those points. Okay, got it. Arrows on the end of my dashed line. So anything that lands on this line will not make this thing true because it says strictly greater than. Step 3 says select a point not on the line as a test point. So listen, y'all, pick any point not lying on this line. Like, for example, I'm going to pick way over here. 4, 0 is clearly not on that line, right? So we're going to pick a test point of 4, 0. And it doesn't matter if you pick on the right side or on the left side. Honestly, it doesn't matter, just as long as it's not on the line. Step 4. Says substitute the test point into the inequality. If the statement is true, shade the side including the test point. So if we get a true statement, we're going to shade over here on the right where the test point came from, where it lives. If it's false, I'm going to shade the other side, the left side of this story. Okay? So what am I going to do? I'm going to plug in into the original problem, y is greater than negative 4x plus 1. My y is going to be 0. This test point, right, is greater than negative 4. My x for my test point, remember, was 4 plus 1. And we're just going to see is it true or false. So is 0 greater than, now negative 4 times 4 is negative 16 plus 1. 0 is bigger than negative 15. That's what that says. 0 is bigger than negative 15. That's true. Okay? So what that means is my point is 4 zeros on the right side of my graph. That means everything on the right side of my graph is going to make this problem true. Everything. Forever and ever and ever and ever over to the right. So that is my solution to this inequality. Okay, let's try this again, right? So remember step 1. Step 1 is to graph y equals 1/3 x minus 4. Good news, this is already in y equals mx plus b. My y-intercept over here is negative 4, so I make a mark there first. And then my slope, my m, is 1/3. What does that mean to do? Up 1, right 3. Again, if this is illusion you, go back and watch the videos about graphing and practice a lot of that before you do this. So you count up 1 and write 1, 2, 3. We could do it again, count up 1 and write 1, 2, 3. Next question is, do I do this dashed or do I do this solid? Well, it's a strictly less than problem, which means I graph this with a dashed line as best we can. There we go. There's our dashed line. Step 3, I want to pick a test point. Pick something clearly not on that line. And y'all, 0, 0 is clearly not on that line. So I'm going to pick 0, 0. Matter of fact, I almost always pick 0, 0. As long as I don't think my line goes through it, I'm going to pick it. Okay? And 0, 0 lives right here. So there's my test point right there. So what am I going to do? I'm going to plug my test point into my original problem. So my y is 0. Is that less than 1/3 times 0 minus 4? And then you simplify. Is 0 less than, well, y'all, that's 0, right? Minus 4. Is 0 less than -4? Nope, it is not. So you know what that means? I don't shade where the test point came from. I shade the other side. So this and all of these points make my inequality true. If you plugged in something on this side over here, I promise you it would give you a true statement. Here we go, cruising right along. Why don't you try to pause this and see if you can get this one yourself. How'd it go? So step 1, remember I'm going to graph y equals -4/5 x plus 2. So the first thing I've got to do is my y-intercept is 2. There it is. And I'm supposed to count down 4, right 5, right? Because m is -4/5. I'm going to take the negative with the numerator, so it's down 4 and right 5 from my y-intercept. So down 4, 1, 2, 3, 4, and then right 5, 1, 2, 3, 4, 5. I could do it again, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Next question is, when I connect the dots, do I do it solid or do I do it dashed? Well, it's a less than or equal to. That equal to means I do solid. So this is a solid line. That's the best solid line I can do at the moment. There we go. Step 3, we need a test point. We need to test some point that does not live on that line. And 0, 0 to me looks perfect. The line has no chance of going through 0, 0. It's right here. Okay? So if it's true, I'm going to shade this side. If it's false, I'm going to shade the other side. So I have 0 is less than or equal to, 0 is less than or equal to -4/5 times 0 plus 2. So I have 0 is less than or equal to 2. Is that true or is that false? Well, that is a true statement, right? So that means since it's true, I shade the same side that 0, 0 lives on. So I shade all of this. Every bit of this gets shaded. All right, so step 1, we're supposed to graph -2x plus 4y is equal to 12. Now this one's not so straightforward, right? This is not in y equals mx plus b form. It's easy to get it there, though. The first thing I need to do is move my x term to the other side. So now I have 4y is equal to positive 2x plus 12, and I divide everything by 4. So that gives me y is equal to 1/2, reduce to 2/4, x, and then 12 divided by 4 is 3. So my y-intercept is 3, so I make a mark at 3, and I rise 1 and run 2, right? So from here, rise up 1, run 2, rise up 1, run 2. I can do it again, rise up 1, run 2. There's my straight line. Now, do I do dashed or solid? Notice I don't say that the same order every time. Is it dashed or solid? Well, the less than or equal to means I'm dealing with a solid. Equal to always means solid. So there's my solid line. Now I need to pick a test point, right? So I'm going to test this point right here, 0, 0, because he's my favorite. And I'm going to plug that into my original inequality right at the top. So -2 times 0 plus 4 times 0 is less than or equal to 12. Well, that's all 0 on the left. Is that less than or equal to 12? That's true, right? So I shade the side with 0, 0 on it. I shade this side, And everything that I've got shaded in, including the line, because it's solid, is going to make this inequality true. All right, next problem. Once again, 5x plus 3y is less than 15. Go ahead and try it yourself. When you come back, see if we get it right. So step 1, I'm supposed to graph 5x plus 3y equals 15. Well, to do that, I have to solve for y, right? So I'm going to subtract the 5x over, move the him over here, which changes the sign, negative 5x plus 15. I divide each one of these guys by 3. So I get y is negative 5/3 x plus, and then 15 divided by 3 is just 5, which means I have a y-intercept of 5, and I'm supposed to go down 5 and right 3. So 1, 2, 3, 4, 5, and then 1, 2, 3. Gives me both of my axes, actually. Now, question is, do I need a solid or a dashed line? Well, I need a dashed line because of just strictly less than. So strictly less than or greater than is going to give me a dashed line. And what that means is the line is actually doesn't produce any solutions. That's why it's dashed. Step 3, I need to pick a test point. You know what I'm going to pick? 0, 0. 0, 0 is my test point. In step 4, I'm going to plug my test point into my original problem, which is 5 times 0. I've got it kind of marred up here. Let's erase that. 5 times 0 plus 3 times 0 is less than 15. That gives me 0. Is 0 less than 15? Sure is. That's a true statement. So 0, 0 is right here, so I shade every single point that is on the bottom left side of my line, and that makes that inequality true. All right, I give you plenty of these to practice, okay? So step 1, we want to graph x minus 2y is less than or equal to 8. So to do that, I got to move that x over there, right? So negative 2y, when I move it to the, oh, this is supposed to be equals, by the way. That's what I get for mindlessly copying. Negative 2y is equal to negative x when I move it to the other side, and then plus 8. Now I divide every one of these terms by negative 2. So it gives me y is equal to, now these two negatives, you know they cancel, and there's really a 1 living in front of that x, so you might want to write it as 1/2 x, and then 8 divided by negative 2 is minus 4. So my y-intercept is negative 4. I make a mark there, and then I count up 1, right 2. So up 1, right 2, up 1, right 2, up 1, right 2. Okay? Going too fast, just slow down and look at it and make sure that makes sense. Now, next question, do I need a solid or a dashed line? Well, we need a solid line because of the greater than or equal to right there. So I connect these dots with a solid line. That means everything on that line would make the inequality true. Step 3, let's pick a test point. Once again, anytime I can pick 0, 0, I do. And how do you know you can pick it? If it doesn't lie on your line that you just graphed, you can pick it. So I plug that into my original problem, 0 minus 2 times 0. Is that less than or equal to 8? Well, is 0 less than or equal to 8? Sure is. I'm giving you the impression that every time you pick 0, 0, it's true. It's not. It's not always true. It just happens to be these problems that I'm doing here. So there's my solution, all shaded. I got 3 more problems for you. They'll be quick, okay? So I've got y is greater than or equal to negative 3x. Step 1, I've got to graph y is equal to negative 3x. Now don't freak out on me. You're looking at this, it's y equals, like it's supposed to be, right? But there's no b. You're right, there's no b. It's 0. There's my slope. I can write it as negative 3 over 1, and there's my b. So my b is right here, and now I'm supposed to go down 3 and right 1. And down 3 and right 1. Now, next question, do I do solid or dashed? I do solid because of the equal to. Greater than or equal to or less than or equal to, doesn't matter, is always a solid line. So I connect the dots with a solid line. And then I pick a test point. Now, I cannot pick my favorite guy. 0, 0 is on my line. So what do I pick? I don't know. What's wrong with 3, 0? It'll work just fine as long as it's not on the line. So I plug that into my problem, my original inequality, 0 is my y, so I say 0 is greater than or equal to negative 3 times 3. Is that true or false? 0 is greater than or equal to negative 9. That's true. So I shade the side that my point lives on. If I got false, I would just shade the left side. I would shade the other side, but I got a true statement. So there's our solution. All right, let's follow our rules. So step 1 are our steps. We're supposed to graph y equals negative 3. Now, at first you're like, oh my goodness, what's going on? There's no x. Remember, y equals is a horizontal line at negative 3. So at negative 3, right here, I do a horizontal line. Question is, do I do it dashed or solid? So is it dashed or solid? It's dashed, right, because of the no equal to up here. So I do a dashed line down here at y equals negative 3. And then I pick a test point. 0, 0 is not on that line, right? 0, 0 is right here. So I'm testing this guy right here. Now, step 4, you plug it in. Now, there's no x up there, so there's nowhere to plug in the first 0, but the second 0. Is 0 less than negative 3? That's false. Finally got a false, right? So I don't shade the side with 0, 0 on it. I shade the other side. So this time, finally, the opposite side. So below the line, that makes sense. Y is less than negative 3 ought to be numbers less than negative 3, and that's what we shaded in. And our last, not least, just our last problem, graph x is greater than or equal to 2. So step 1, we're going to graph x is equal to 2. Now again, this crazy guy's missing a y, right? But we know when we have just x equals a number, that's a vertical line. Okay, so vertical line, where is it? It's at x equals 2. Now, next thing, do we do a solid or a dash? It's solid because of the equal to part. So at x equals 2, I graph a solid, woohoo, it disappeared on me, a solid vertical line. And there it is, okay, my solid vertical line. Now I'm going to pick a test point. So I'm going to test 0, 0 because it's right here, and I can test that. All right, so when I plug that into my inequality, I don't have anywhere to plug the y, but I do have somewhere to plug the x. So is 0 greater than or equal to 2? It's not. That's a false statement. So I do not shade the left side where 0, 0 came from. I shade the right side. And that makes sense. Look at your original problem. It says x is greater than or equal to 2. Well, that's all the x's that are bigger than or equal to 2. And there it is. So I hope that helps. You have to be good at graphing. If you had trouble with this, go back and watch the graphing videos and then come back and do this. You'll find that it's pretty straightforward and pretty simple to do. Y'all take it easy.